Every star begins as a whisper in a cloud, a drifting cradle of gas and dust, slowly folding under the invisible hand of gravity. Tiny ripples become swirls, swirls become spirals, and at the center, a flame ignites. That flame is fusion, the universe's most sacred act of creation. Hydrogen, the simplest element, fuses into helium under immense pressure. In that moment, matter becomes energy. E equals mc squared, the law written into the bones of every sun. The light we see from a star is not just brightness, it's balance, an endless tug of war between the outward push of heat and the inward pull of gravity. For millions, even billions of years, this balance holds steady. The star breathes, a cosmic heart beating in silence, its light traveling across time to touch worlds it will never know. But nothing in the universe stays forever young. Even stars must grow old. As the hydrogen runs dry, fusion in the core begins to falter. The star, desperate to survive, turns to new fuels: helium, carbon, oxygen. Each stage burns faster than the last, as if the star senses the end approaching. Its outer layers swell into a red giant, and its glow softens to a dying ember's hue. But inside, pressure builds. Gravity begins to win the war. The core collapses inward, atoms crushed so tightly together that protons and electrons fuse into neutrons. In that instant, the heart of the star becomes denser than an atom's nucleus, a city's mass squeezed into the size of a mountain. The collapse releases a burst of energy so vast that it tears the universe open for a moment. The star's life, millions of years of steady burning, ends in a single second of violent surrender. Then comes the roar. The collapse halts, and all that inward motion rebounds outward in an explosion so fierce that space itself seems to shudder. A supernova, the grand finale of stellar existence. For a few shining weeks, one dying star burns brighter than an entire galaxy of billions. Its light travels for thousands of years, crossing the darkness to one day reach the eyes of creatures who will name it, study it, and wonder. In that furnace, new elements are born: iron, gold, uranium, the raw materials of planets, oceans, and bones. Every atom of calcium in your teeth, every atom of iron in your blood was once inside the heart of a star that died this way. A supernova is not destruction. It is transformation, a single moment where death becomes creation. When the blinding light fades, the story is far from over. The universe does not close its book on a dying star. It turns the page. The explosion rips apart space itself. Matter, light, and radiation racing outward at speeds so high they blurred the boundary between motion and existence. For a few heartbeats of cosmic time, the star's remains outshine galaxies, illuminating worlds that may not yet exist. But light is only half the story. The other half, quieter, colder, is written in the dust and ash that follow. Those ashes are not waste. They are raw material: hydrogen, helium, carbon, oxygen, silicon, iron, nickel. Each atom is a survivor of nuclear war, forged in heat 1 billion times greater than any flame. And as that stardust spreads across the void, it slows, cools, and begins to gather again. Tiny particles meet by chance, bond through gravity's whisper, and over millions of years, the wreckage becomes a nebula. A vast, luminous cloud glowing with the ghost of its parent star. Inside these nebulae, new stars begin to form, born from the remains of their ancestors. It's a cosmic cycle, endless and self-renewing, a truth older than galaxies, that death is not disappearance, but transformation. And yet, while this beauty unfolds across eons, at the very center of the explosion, something far stranger endures. The core, the dense heart that refused to break. If the star was merely large, it leaves behind a neutron star, a city-sized sphere heavier than the sun, where atoms no longer exist as atoms, but as a sea of neutrons packed tighter than imagination allows. Its magnetic field is 1,000,000,000,000 times stronger than Earth's, and its surface smoother than glass, yet harder than diamond. If you could stand upon it, you'd be crushed before thought could form. It spins, sometimes hundreds of times per second, and as it turns, it sends out radio light like a celestial lighthouse. We call them pulsars, blinking rhythmically through the endless dark. But if the star was truly massive, 10, 20, 30 times the sun's weight, then even neutron matter cannot resist. Gravity folds the universe inward upon itself. Light can no longer escape. Time begins to curve. And what remains is a black hole, the most mysterious child of creation. To speak of black holes is to step beyond human language. They are places where our equations begin to whisper instead of shout. A black hole is not a thing, but an absence, a region of space-time so warped that all directions point inward. At its center lies what physics calls a singularity, a point of infinite density where the known laws of the universe collapse under their own weight. Around it stretches the event horizon, the invisible boundary beyond which no information can return. Not light, not time, not memory. But even here, the story doesn't end in silence. Black holes are not static monsters we once believed them to be. They spin, they hum, they distort the space around them like glass beneath heat. They feed, yes, on gas, dust, and sometimes entire stars, but they also create. Around their edges, matter whirls in a furious dance, heated to millions of degrees, emitting X-rays and radiation that astronomers can see from across the cosmos. The very heart of galaxies, including our own Milky Way, is sculpted around such a black hole. It is called Sagittarius A. And though it lies 26,000 light-years away, it holds the galaxy together like an anchor. Without black holes, galaxies would drift apart. Stars would lose their rhythm. The cosmic dance would dissolve into silence. So perhaps a black hole is not a void, but a kind of memory, a place where the universe keeps what it cannot yet understand. Even Stephen Hawking once said that information may not truly disappear there, it may only be transformed, encoded in radiation, waiting for a future mind to read it. Maybe, in ways we cannot yet grasp, black holes are not tombs, but libraries, where the universe writes its most secret truths.
The shock waves from supernovae ripple outward for millions of years. As they travel, they press against the gas clouds of interstellar space, triggering the birth of new stars. Each generation of stars builds upon the ashes of the last, richer in elements, more capable of giving rise to complex chemistry, to planets, to oceans, to life. When our own sun was born, it inherited this legacy. It carries within it the dust of long-dead stars that once burned, collapsed, and scattered. The Earth itself was built from that debris, from iron forged in another sun, from carbon born in another flame. Even your body, every atom that makes you, was once part of a star's final breath. the calcium in your bones, the oxygen you inhale, the gold on your finger. All are ancient, recycled by the universe from the remnants of a dying sun. So when we say we are stardust, it is not poetry, it is physics. It is the truest story we know. And if that is true, then perhaps the universe is not cold after all. Perhaps it dreams through us. Perhaps when we look at the night sky, we are the cosmos looking back at itself, remembering. Gravity is the great sculptor of existence. It builds the stage, directs the actors, and writes the script of the cosmos in curves of space-time. When a massive star dies, its explosion doesn't just scatter matter, it reshapes gravity itself. The blast waves ripple outward, their force bending the surrounding space like fabric struck by wind. These waves, called gravitational waves, were first predicted by Einstein, and a century later, we finally heard them. In 2015, two neutron stars collided, and detectors on Earth trembled with their echo. We had, for the first time, heard the sound of gravity speaking across the universe, a low, ancient note that began long before life existed here. Every collision, every supernova sends out such ripples, carrying information not just of destruction, but of structure. How much mass was lost, how violently space-time folded, how the universe itself flexed to absorb the shock. It is as if the cosmos has a rhythm, and every dying star contributes a note. Gravity is the music of time, and we are just now learning how to listen. But this symphony has another side, a slow, steady counterpoint that shapes galaxies. The gravity left behind by dead stars acts like invisible architecture. It draws gas into new spirals, compresses clouds into new suns, and spins galaxies into the graceful wheels we see through telescopes. Even the dark matter, that invisible, undetectable substance making up most of the universe's mass, is part of this design. We cannot see it, but we can feel its pull in the way galaxies refuse to fly apart. And so the death of a star is not an isolated tragedy. It is a single chord in the unending song of gravity that has been playing since the first light was born.
The universe appears chaotic. Explosions, collisions, entropy rising, and yet beneath the chaos, there is exquisite precision. Stars explode not at random, but in patterns defined by physics, so consistent that across billions of light years, the same processes repeat themselves. The laws that governed the first star's death are the same that govern ours. They have not changed in 13.8 billion years. This order is written into the periodic table itself. Each element is a story of fusion and collapse. Hydrogen and helium from the Big Bang, carbon and oxygen from ordinary stars, iron and gold from supernovae, uranium and thorium from neutron star collisions. Every atom carries the memory of its birth, its energy signature, its resonance in the cosmic equation. Scientists call this nucleosynthesis, but in truth, it's more like a scripture, a hidden language through which the universe records its evolution. Even chaos serves order. Entropy, the slow unraveling of structure, drives creation itself. Stars burn because they're losing order, and planets form from the debris of that loss. Life, too, thrives on imbalance. Every breath you take, every heartbeat, is a local rebellion against entropy. You live because the universe cools. And so, even in death, when a star collapses, when its atoms scatter, it is participating in a vast equilibrium, a balance so subtle that allows existence itself to happen. To understand the universe, you must see this not as chaos, but as choreography. The supernova is not random fire, It is a precise note in a vast mathematical composition. In the aftermath of the explosion, time behaves differently. Gravity does not just pull on matter, it pulls on time itself. Around a black hole, seconds stretch into eternities. If you could hover near one's edge, the event horizon, you would see the entire future of the universe unfold in an instant, while to distant eyes, you would appear frozen, never crossing the boundary. This is not science fiction, it is relativity in motion. Time is elastic, woven into the geometry of space. When the star collapses, its mass curbs space-time so steeply that time nearly stops within it. Astronomers call this the gravitational time dilation, but poets might call it the death of time, the moment when eternity folds in on itself. And yet, within that frozen silence, quantum laws whisper something different. Particles flicker, information dances, and even black holes leak a faint breath of energy, hawking radiation. If that's true, then even the most absolute darkness is not eternal. Over trillions of years, a black hole evaporates, its energy returning to the cosmos as faint warmth. Time, it seems, cannot die completely. It can only change its rhythm. When we speak of stars, we're not just speaking of astronomy. We're speaking of origins, of memory, of purpose. Every civilization that ever looked up felt the same awe, the same question pressing against the mind: what am I? And the answer, whispered by science and silence alike, is this: you are the universe made conscious. You are stardust that learned to dream. You are the cosmos reflecting upon its own birth. Your thoughts are patterns of energy, not unlike the magnetic fields of pulsars or the waves of radiation that echo from supernovae. When you die, your atoms will return to the same process: scattered, reused, reborn. The cycle that built the galaxies will one day rebuild you in another form, under another sun. The universe wastes nothing. It transforms everything. So when you look at the night sky, you are not looking outward. You are looking backward, into the deep memory of what you were made of. Every star is both a beginning and an ending, a mirror showing us the poetry of impermanence. And maybe that's the deepest truth, that beauty exists because things end. A star explodes, a galaxy spins, a consciousness wonders, and together they write the one story that has no beginning and no final line. The universe is not a random scattering of stars. It is a web, a vast, delicate lattice of matter and energy. Supernovae are the threads in this web. Their explosions push, compress, and pull. They carve cavities in nebulae, trigger the birth of new stars, and align galaxies along invisible strands of dark matter. Astronomers call this the cosmic web, a pattern spanning hundreds of millions of light years, where matter collects into filaments and voids stretch like the empty spaces between thoughts. The death of a single star may seem insignificant, but multiply it by billions, and you see the architecture of the cosmos emerge. Every shockwave, every photon, every neutron-rich particle is part of the scaffolding of existence. Gravity and energy dance in this architecture, and in that dance, life eventually finds a way. Planetary systems form, habitable zones appear, and somewhere intelligent life may look back and name the stars that made it possible. The cosmos is not chaos, it is organized imperfection, built from billions of endings and a few persistent beginnings. While gravity shapes the local, a mysterious force stretches the universe at large. Dark energy, the name we give the unknown, pushes galaxies apart, accelerating expansion, whispering that the universe is growing faster than light could travel from its earliest birth. Supernovae are our rulers for this force. Type 1a supernovae, the exploding remnants of white dwarfs, act like cosmic mile markers. By observing their light across billions of years, scientists discovered that the universe is not slowing down, but speeding up. It is humbling. Even the grandest explosions, even the deaths of massive stars, cannot halt this silent sculptor. Yet, dark energy does not destroy. It allows space to expand, time to stretch, and complexity to emerge. Without it, galaxies might collide too soon. Stars would be swallowed by gravity, and life would struggle to exist. The universe is balanced between two forces: the collapse of gravity and the expansion of dark energy. In the tension between them, cosmic life, galaxies, stars, planets, and consciousness finds its rhythm. Beneath the grandeur of stars and galaxies lies the subtle world of quantum mechanics. Here, particles flicker in and out of existence, probabilities govern reality, and even empty space hums with virtual energy. Supernovae, black holes, and neutron stars all interact with this quantum fabric. Neutrinos, almost massless particles, escape the dying core before light does, carrying whispers of the explosion across space. Quantum mechanics also hints at universes beyond our own. Each star that dies may be part of a larger multiverse, where countless versions of matter and energy play out infinite possibilities. Every explosion, every atom scattered, resonates through this invisible weave. We are connected not only to the cosmos we see, but perhaps to those we cannot. The quantum world is the bridge between the catastrophic and the creative, between death and rebirth, between matter and mind. Stars burn, explode, and fade. Galaxies collide. Black holes consume. Dark energy stretches space ever outward. All of this points toward a distant fate, a universe slowly running out of energy. Scientists call this the heat death, a time when stars burn out, galaxies drift apart, and all processes reach equilibrium. Yet, even in that extreme, there is a form of continuity. Energy cannot be destroyed. Matter transforms. Information persists in subtle ways, encoded in radiation, in gravitational waves, or perhaps in forms we have yet to understand. Even the end of time, if such a thing exists, is not emptiness. It is transformation on a scale beyond imagination. Every supernova, every black hole, every pulse of stardust contributes to this ultimate story. A story without a clear beginning or end. A universe in which death is merely a transition. Finally, we return to ourselves. The atoms in our bodies, the thoughts in our minds, the sense of wonder when we gaze at the night sky, all are the echoes of stars long gone. We are not separate from the cosmos. We are its memory, its reflection, its consciousness. When a star explodes, it scatters not just matter, but information. It tells future observers, billions of years later, here I was, I existed, I created. Every human question, every act of curiosity, every attempt to understand the universe is a continuation of that message. To witness the stars is to witness ourselves. To study supernovae is to study the poetry of existence. We are stardust contemplating stardust, gravity shaping thought as much as matter, quantum threads weaving mind into matter, and time itself folding to allow memory, reflection, and meaning. The death of a star is not loss. It is a story of transformation, of eternal creativity, and of consciousness emerging from the cosmos itself. Not all stars end quietly, even among the dead. Some remnants become magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. Imagine a force so intense that it could erase a credit card at a distance of 1 million kilometers. Magnetars are the universe's wild hearts. Their surfaces crack under magnetic stress, sending out X-ray flares that briefly outshine the Milky Way. These flares, though distant, teach us something profound. Energy can be concentrated in forms almost incomprehensible to human imagination. The universe is capable of extremes, reminding us that scale matters. Our daily worries are whispers beside the roar of stellar death. Magnetars also hint at hidden cosmic order. Their births require precise conditions: a massive star, rapid rotation, and magnetic amplification. Too little or too much rotation, and the star ends as a simple neutron star, or collapses into a black hole instead. The universe, in its fury, still follows rules. Even chaos has its own geometry.
Some stars die with a burst so intense that they can be detected across billions of light years, gamma-ray bursts. These are the universe's lighthouses, brief, catastrophic, and brilliant beyond measure. A single burst can release more energy in seconds than the sun will emit over its entire 10 billion-year lifetime. Gamma-ray bursts also remind us of fragility. If one occurred too close to Earth, it could strip the atmosphere and reset life's clock. Yet these events also fuel creation. Their shock waves enrich space with heavy elements, seeding future stars, planets, and perhaps life. A gamma-ray burst is a paradox: destruction and creation, light and darkness, violence and promise, all compressed into a heartbeat of the universe. Stars do not live in isolation. Their explosions shape entire galaxies. Supernovae compress gas clouds, triggering stellar nurseries where new stars ignite. They sculpt the spiral arms of galaxies, clear paths for cosmic winds, and regulate star formation, keeping galaxies from burning too fast or collapsing. Through billions of years, galaxies evolve in response to the life and death of their stars. Collisions create new structures. Black holes anchor them. Dark energy stretches them outward. We are witnesses to a slow, grand symphony. Every star a note, every explosion a chord, and every galaxy a movement in a cosmic symphony that has been playing since time itself began. Watching stars explode teaches us more than physics. It teaches perspective. Nothing lasts forever. Not stars, not planets, not even galaxies. Yet, in impermanence, creation thrives. The universe does not cling to forms. It recycles, transforms, and repurposes. Philosophically, this mirrors human existence. Our lives, too, are brief flashes of energy, shaping the space around us, leaving echoes in memory, in matter, in thought. Every collapse, every explosion is a lesson in humility. The universe is vast, indifferent, and yet magnificent in its relentless creativity. The atoms in our bodies carry the signature of supernovae. The carbon in our cells, the calcium in our bones, the iron in our blood, all were forged in the hearts of ancient stars. Consciousness is the universe reflecting upon itself. When we ponder a supernova, we are engaging in cosmic memory, remembering the light that traveled billions of years, connecting past to present, matter to mind. Our thoughts, our science, our art, they are all extensions of these stellar legacies. By observing, by understanding, we continue the story of the stars, writing ourselves into the universe's long, unfolding poem. Not all stars end in violent explosions. Some smaller stars, like our sun, conclude their lives as white dwarfs, dense, hot remnants, roughly the size of Earth, yet holding half the mass of the sun. White dwarfs are quiet, but their existence is profound.
They are stellar embers, glowing softly for billions of years before cooling into black dwarfs, silent relics of nuclear fires long extinguished. These remnants are laboratories of physics. Their matter is degenerate, electrons squeezed together to resist further collapse. This electron degeneracy pressure defies gravity, allowing the star to remain stable for eons. Occasionally, if a white dwarf accretes matter from a companion, it can reach a critical mass, the Chandrasekhar limit, and reignite in a Type 1a supernova, shining as a standard candle across the universe. Even in stillness, white dwarfs hold the power of creation. Their quiet persistence reminds us that cosmic significance is not always measured by violence, but by endurance, influence, and the passage of time. Stars are rarely solitary. Some are born in pairs, orbiting one another, their fates intertwined in an eternal dance. When these stars meet, the results can be astonishing. Binary mergers produce bursts of energy, forge heavy elements, and sometimes birth gravitational waves detectable across billions of light years. When neutron stars collide, the event releases an enormous amount of energy in a brief moment, a kilonova. This is the universe creating gold, platinum, and rare heavy elements in a fraction of a second. Such mergers reveal a startling truth. Destruction often precedes creation. When matter is smashed, rearranged, compressed beyond imagination, it yields new possibilities, new materials, and new cosmic stories. Even life itself mirrors this process. Conflict, collapse, and recombination often lead to transformation. The universe is not merely a stage of accidents. It is a forge where complexity arises from extreme conditions. While stars and explosions are visible, the majority of the universe is invisible. Dark matter is the silent architect, weaving structure across galaxies and clusters. It exerts gravity, shapes stellar orbits, and guides the formation of cosmic filaments. Without dark matter, supernova shock waves would dissipate too quickly, galaxies would fail to form coherent structures, and the universe we inhabit would be drastically different. Yet we cannot see it directly. Its presence is inferred from the movement of stars, from gravitational lensing, from the cosmic microwave background. Dark matter reminds us that unseen forces often govern what we perceive. Stars explode, black holes spin, and humans observe. But the true structure of the cosmos is written in shadows. Every supernova sends light across the void, but even light has limits. The universe is expanding, stretched by dark energy. Distant galaxies move away faster than photons can travel. Some light will never reach us, and some stars we see today may already have exploded or vanished billions of years ago. This is the concept of cosmic horizons, boundaries in space-time beyond which information cannot reach us. It's humbling. Even the brightest fireworks of the universe may remain forever hidden. Yet within these limits, each supernova, each gamma-ray burst, every flash of stellar energy carries the history of creation. They are letters from the past, illuminating the present, teaching patience, scale, and wonder. The universe is vast, but every photon that reaches us is a gift, a whisper of truth from a star long gone. Every explosion, every collapse, every stellar death is an illustration of entropy in action. Energy flows, matter transforms, and systems evolve toward disorder. Yet within this universal trend emerges complexity. Planets, ecosystems, intelligence, consciousness. Life, in a sense, is a rebellion against entropy, a temporary pocket of order carved from chaos, sustained by the fusion of stellar energy. When we contemplate a supernova, we are confronting our own impermanence. We see that creation arises from destruction, that endings are beginnings, and that time itself is both relentless and poetic. Cosmic reflection teaches humility. Our lives are brief, our presence fragile, yet we are composed of the most ancient materials in existence. Stardust has learned to think, to question, to wonder, and in doing so, the universe becomes self-aware. Every stellar explosion is not merely a physical event, it is a cosmic lesson that death is transformation, that impermanence fosters creativity, and that consciousness is the universe's way of remembering itself.
Some galaxies harbor supermassive black holes that feed on surrounding gas, creating quasars, incredibly bright, luminous beacons visible across billions of light years. Quasars remind us that cosmic energy is not uniform. Matter falling into a black hole is transformed into radiation, shining with the power of trillions of suns. They illuminate the universe's infancy, revealing the structure and evolution of galaxies long gone. In a way, quasars are the memory of creation itself, telling us how stars, black holes, and galaxies learned to dance together in the first billion years after the Big Bang. Pulsars, spinning neutron stars, serve as nature's most precise clocks. Their radio pulses are so regular that astronomers use them to detect gravitational waves, measure galactic positions, and even test Einstein's theories. In their rhythm, we find echoes of the universe's heartbeat. They are reminders that even in collapse, order and precision emerge from chaos. The cosmos is not random, it is structured, a lattice of time, motion, and energy. Section 28. Cosmic Recycling, the Life of Elements. Every explosion contributes to a cosmic recycling program. Carbon, oxygen, nitrogen, iron, all essential for planets and life, originate in stars. When supernovae scatter these elements, they seed future generations of stars, planets, and even life itself. The Earth's oceans, atmosphere, and biosphere are literally made from ancient stellar remnants. This is the alchemy of the cosmos: matter transformed, recycled, and given new purpose. Galaxies themselves are not static. They collide, merge, and reshape over billions of years. During these colossal events, stars may be ejected, black holes may merge, and new star formation is triggered in the chaos. Even the violence of galaxies fosters creation. It is a dance of destruction and renewal, echoing the principle that endings are rarely final. They are transitions, portals to new possibilities. Gravitational waves carry the echoes of cosmic events, colliding neutron stars, merging black holes, even the supernovae of massive stars. They are whispers of space-time itself, traveling billions of years to reach detectors on Earth. Listening to these waves, we are hearing the universe speak, a language of rhythm, mass, and motion that transcends light and matter. Every wave encodes information about cosmic history, reminding us that the universe is a network of connections, dynamic, alive, and deeply intelligent in its structure. Not all stellar deaths are explosive. Many stars fade gradually into white dwarfs or black dwarfs, cooling quietly over trillions of years. Even in silence,
They shape their surroundings. Their radiation influences nearby interstellar clouds. Their gravity tugs on companions, and their slow decay ensures that the cosmic cycle continues. In this quietness, we learn patience. Even in the absence of spectacle, existence persists, change occurs, and life finds ways to emerge. The universe operates on timescales that dwarf human experience. Stars live millions or billions of years. Galaxies evolve over billions of years. Black holes endure for trillions of years. In contrast, human life is fleeting, a heartbeat against the backdrop of eternity. Yet this perspective is not discouraging, it is inspiring. We exist in a universe vast enough to contain us, ancient enough to shape us, and complex enough to teach us humility and wonder. Entropy drives the universe toward disorder, yet complexity arises within it. Life, consciousness, galaxies, and even thought are pockets of order carved from chaos. Every supernova, neutron star, or black hole contributes indirectly to this emergence, reminding us that the universe is not just destructive, but profoundly creative. In watching stars explode, we witness the interplay between chaos and order, between energy and structure, between impermanence and persistence. The atoms in our bodies, carbon, oxygen, iron, originated in ancient stars. Our very existence is a reflection of the cosmos. Consciousness is the universe contemplating itself. Through thought, observation, and reflection, we continue the narrative of stellar creation and destruction. Every observation we make, every question we ask, is a continuation of the cosmic story, a bridge linking stardust to mind, matter to meaning. As we end this chapter of cosmic exploration, we pause in awe. Stars will continue to explode, black holes will merge, galaxies will collide, and the universe will expand ever outward. We too are part of this unfolding story. The atoms in our bodies, the thoughts in our minds, the dreams we dream, all are echoes of stellar history, continuations of creation itself. The universe is not distant. It lives within us. It is in our blood, our bones, our curiosity, and in the quiet wonder we feel when we gaze at the night sky. This reflection is gentle, not a conclusion, but a pause, an invitation to continue observing, questioning, and participating in the eternal, unfolding story of existence.